This is Sandeep from Artificial Intelligence and Data Science Department, third year. Now I am going to explain about implementation of a simple multi-layer perceptron, which is MLP, which is experiment number 3 in neural networks. The main objective of this experiment is to implement a simple multi-layer perceptron from scratch using Python and NumPy. The MLP is trained on a small data set to classify binary inputs. The aim is to understand the basics of forward propagation, back propagation, and the training process of a neural network, as well as to visualize the loss function to ensure the model is learning. The step-by-step code implementation is, in the starting we'll be importing the libraries, which is numpy as np and pandas as pd, and we'll be importing io and importing matplotlib.pyplot as plt for plotting the graphs. uh, for the input data and parameters, we'll be defining the input data x and the corresponding labels y. We'll be setting the network parameters, number of input features nx, number of hidden units nh, number of output units as ny, and the number of training examples as m, and the learning rate as lr. Now we'll be initializing the weights. Initialize the weight matrices w1 and w2 with random values. We'll be defining the activation function, implementation of the sigmoid activation function. Next, we'll be seeing the forward propagation function with weight 1, weight 2, and x. We'll be computing the activations for the hidden layer and output layer, and we'll be returning the computed values for using back propagation. Next, we'll be seeing the back propagation function. We'll be computing the gradients of the loss with respect due to the weights, and update the weights using the computed gradients and learning rate. And now we'll be training this thing. We'll be running forward propagation to get predictions. We'll be calculating the loss using the binary cross entropy loss function, and we'll be performing back propagation to update the weights. We'll be appending the loss to a list for visualization. Yeah. And this will be the output, like we'll be plotting the loss curve over iterations to visualize the training process, predict function, and define a function to predict the output for the given input using the trained weights. The execution of this program is the multi-layer perceptron is trained on input data for 10,000 iterations. During training, the loss is calculated and stored for each iteration. The loss curve is plotted to visualize the learning process. The trained model is used to predict the output for various test inputs. The results are to plot the shows the decrease in loss over iterations, indicating that the model is learning. The predictions for the test inputs are displayed. For the given inputs 1 comma 0, the output will be 1. For the second given input 1 comma 1, it will be 0. For the next thing 0 comma 1, the input will be 1. For the last input 0 comma 0, the output will be 0. These inputs and outputs are following the XOR operation for the implementation. The applications of an MLP can be like classification tasks, regression tasks, facial recognition, pattern recognition, handwriting recognition, speech recognition, function approximation, and time series prediction.